Watch that boulder on the upper belt.
I see it. Keep an eye on the pressure. See that weepage right there?
Yeah, I got it. Let's hit that connection.
Thrust pressure is too high. Decrease the advance rate, we're off center to the right.
Roger that. Adjusting controls.
The segment erector arm in operation, placing a curved, precast concrete lining segment into the crown position of a newly completed
is the Channel Tunnel service tunnel, the smallest of the 3 bores that form the complete tunnel system, stretching roughly 50 kilometres.
We positioned the 3 bores within the chalk marl, ensuring sufficient rock cover. Note the contrast as we transition to
The camera transitions to show the French portal site at Coquelles near Calais.
I've marked the primary fault line here at the center of the route. We need to ensure the casing design accounts for this specific chalk marl thickness.
As you can see, the chalk marl is compact and fine-grained. This uniform structure with no visible fractures is
These large span excavations for the crossover chambers required special support using the new Austrian tunnelling method.
Rate of penetration confirms we are in the chalk marl layer. Keep the rotary speed steady.
Copy that.
Circulating samples are coming up now.
Watch the table. Easy now.
Okay, let's check the RQD on this section. The chalk marl looks consistent, measuring the orientation here.
Look at the graph. The permeability is very low.
Yes, this confirms the lab results for the chalk marl.
The point load strength index is steady at 2.5.
Good. Enter that into the database for the TBM design calculations.
Didn't
Look at the aperture on this bedding plane, much wider than the core suggested.
RQD is definitely lower here.
We've optimized for the chalk marl, but these mixed face zones require TBM close mode.
And the fault zones need additional grouting before we tunnel.
The French side presents complex geology and potential water inflow risks.
What if conditions exceed the predicted range?
All right, slowly back now.
Keep it coming back. Crane is clear above.
And stop. Hold it there.
the construction of the tunnel launch shafts on both the English and French sides, where the TBMs are lowered into the ground and positioned for their underground journey.
We are aligned with the keyways. Set it down easy.
Roger, setting it down. Clear the landing area.
Okay, rue the automatic cycle now.
Cycle initiated. Pressure holding steady at 200 bar.
Verified. Positional accuracy is within tolerance. High voltage connections certified and secure.
The integration is solid.
All right, test schedule 4B signed off.
engineer monitors the face chamber pressure, making small adjustments to the screw conveyor rotation speed to maintain the design value.
The French slurry pipeline system is an alternative method of excavated material transport used in a closed.
The camera reveals the annular grouting operation that fills the tail void between the outer surface of the newly placed lining rings and the bore of the tunnel cut by the TBM.
We need to increase the advance rate on the north tunnel now. Divert power.
Understood. Communicating the override to the team.
All right, bring it down another 5 millimeters. Watch the clearance. Clear on this side. Gauges are reading good.
The actuators performed within tolerance.
Checking the gasket groove now. Surface looks clean, no honeycombing.
A segment stacker machine places the segments onto rubber-padded timber bearers. The yard uses a first in, the gauge reads acceptable. Gasket check confirmed. You can proceed with installation.
Keep that arm steady. We're hitting a seam. Watch the conveyor speed. Watch the alignment on that coupling. Got it, pushing it in now. All right, bring it down slowly on your side. Okay, steady, steady. Looks aligned now.
Ensure the gland is fully tightened at this point. This connection is secure. Go ahead and mark it.
Keep the feed smooth back there.
Roger that. Tension is stable, no kinks detected.
Did you connect the aspirating tubes to the central unit?
Yes, and the water supply valve is secured open. We can move to the phones.
A drainage engineer conducting a hydraulic performance check on the completed drainage channel sections by measuring the channel gradient and section geometry.
The comparative analysis confirms the alignment. The deviation is minimal.
Excellent. We have a confirmed breakthrough position.
Check the French coordinates again.
We are within tolerance, but the deviation is increasing.
Cross-reference the laser data immediately.
The breakthrough procedure is formally authorized. We can proceed.
We've broken through! Monsieur, the alignment is perfect. Well done.
Horizontal deviation, 5 millimeters. Vertical, 2 millimeters.
Unbelievable precision. We did it.
Watch the alignment on the left side. Okay, secure the panel now. We need more wire over here. We did it. The connection is secure. Excellent work. Congratulations, everyone. Hooray! Well done, everyone. Bravo! We made it through.
The corrections have been applied. The convergence rate is holding steady at the predicted axis.
The breakthrough is complete! Well done, everyone. We finally made it. We need a slight adjustment on the left.
Okay, adding concrete now.
Slow down the winch. Watch the base.
Steady, steady. Guide it onto the sleeper now.
Adjust the registration arm on the left. We need the correct stagger here. Moving it 5 millimeters outboard. How is that?
Leader. Initiating the full ventilation sequence now. Monitor the pressure differential.
Measured values are slightly below target in zone 3.
The piston effect calculations align with the measured air velocity.
Agreed. We can authorize the next speed increase.
This way to the safe tunnel.
Hurry, please.
Single file through the door. Keep it moving.
Control, we have a confirmed ventilation failure in section Charlie.
Acknowledged. Divert all trains to the alternate tunnel immediately. Activating emergency fans.
This is incredible, isn't it? Look at that light change. We're going so fast.
Yes, Calais, we have a slight delay on the eastbound bore. Hold the 1400 freight until the block clears at Folkestone.
Rail wear on the high side is reading 5.2 millimeters.
Noted. Check the gauge at the crossover.
Warning. Critical deviation detected on overhead line parameters. Intervention required before service resumes.
Purpose, educational purpose and informational purpose. Using advanced AI tool and human creativity, all concept scripting and storytelling are independently developed to ensure originality. Visuals and animation are enhanced using AI technologies such as View 3, Meta AI and Grok AI, while final editing and post-production are completed using CapCut and other professional editing tools. No external creator content has been copied or used any resemblance to real world environment, factories or processes is purely coincidental. All scenes shown in this video are digitally created and do not represent real footage. This content is produced with transparency and follows YouTube monetization guidance. Thank you and subscribe for more real videos. Manufacturing Factory.